Hello everyone, welcome back to our channel, which name is Analytics Pro. Here under this playlist guys, we are going to cover SQL concepts from scratch. In the previous tutorial guys, we have discussed about 4th normal form and 5th normal form. So I hope you guys are clear with all the forms of normalization. And now in today's tutorial guys, we will discuss one more important topic of SQL, which name is indexing. So let's start our class guys with introduction. And now let's discuss what is indexing. So firstly, let's understand the basic definition of indexing. Indexing in SQL is a technique used to speed up the retrieval of rows from a database table. An index is a data structure that improves the speed of data retrieval operation on a database table at the cost of additional space and some overhead on data modification operation like insert, update and delete. So this technique guys helps you to speed up the process. And in simple word guys, we can say an index is like a lookup table that helps SQL database finds rows faster. You guys can connect with books analogy. Think of it as a table of content in a book. Instead of reading every page to find a topic, you can use the indexing to jump directly to the page. So this process is known as indexing. And now guys, let's learn why we need to use indexing in SQL. So the first point says faster data retrieval, which we have already explained. So whenever you are dealing with a large data set guys, indexing is very useful over there. Indexing allows you to find specific data without scanning through the entire table. And it also reduces input and output cost, which you called IO cost. And this thing guys, I will definitely explain with practical example. But this time you have to keep this thing in mind. Indexing reduce IO cost and indexing mostly used in large table. And indexing are created on table as well as on views. And the next point says it improves performance for queries involving where, join, order by and etc. To facilitate quick retrieval of data from the database, you guys can use indexing. And this features guys comes in 2012 in SQL database. So this is all about why we need to use indexing in SQL for the faster data retrieval and also improves performance, or you can say optimize the queries when you use where, join, order by and so on. And now guys, let me explain how indexing reduce input or output cost. So here we have taken the example. So guys, firstly we have taken CPU, secondly we have taken RAM and third we have taken hard disk. So CPU is a processor guys, which they has to process queries. So in the database terminologies guys, if you enter any command, these are known as queries. So firstly guys, queries comes to this CPU. So let me give you some example of queries like select star from sales. Sometimes you will ask more queries like second highest salary and like select star from where country equal to India. So these kind of queries guys is handled by the processor, which is CPU. And now let's take the example of basic query. And now let's understand with this basic example like select star from sales where country equal to India. So this query execute by CPU. So guys, what do you think? Is this data stored here under this CPU? So no guys, the data is stored in memory. And there are different types of memories in here in this architecture. So we will talk about only two memories here, like RAM, which is volatile. So guys, here volatile means which can change suddenly or unexpectedly. And the secondary memory which is called hard disk. So guys, here RAM is directly connect with CPU. And here CPU speed is million per instruction second. And hard disk is really slow as compared to CPU. So CPU and hard disk speed is not compatible. So that's why guys, data is stored in hard disk. Because here we can store our data permanently. Suppose guys, if you have all the data here under this RAM guys, the moment you shut down your system, your all the data will be lost. So because of that guys, we always store data in the hard disk, not in the RAM, so that it's saved permanently. So once you enter the query guys, it will go to this CPU. So will CPU guys interact with the hard disk? So answer is no, it will not interact because CPU speed is million per instruction second and this hard disk speed is 10-20 million instruction per second and hard disk speed is really slow. So CPU and hard disk speed is not compatible. So guys, here generally data is stored in logical blocks like C drives, D drives, E drives and so on. And let's suppose guys, here data is stored in hard disk. For an example, we have different table stored in this drive. Like sales table we have stored in C drive, employee table we have stored in D drive and department table we have stored in C drive. So in this way, our data is stored in logical blocks here under the hard drives. And generally guys, in the backend, storage manager divided this hard disk and divided into fixed size. And after that, insert into a record. So what we need to think understand here, our CPU is here and our data is stored here under this hard drive. So CPU will not directly interact with this hard drive. So CPU will call to this RAM that I need a data and RAM will call out the data from secondary memory which is hard drive. So if we try to call any query guys, it will process into the CPU. CPU will process to RAM and RAM will retrieve the data to this hard drive where data is stored in logical blocks. So in this hard drive guys, we can store the data into two ways. It could be sorted manner and unsorted manner. So this time guys, I am considering here data is stored in unsorted manner like 53241. So our data is unsorted here in the secondary memory. And now guys, what will happen? Here this entire block of C drives comes into the RAM. And search it guys, whatever the query you have called. So if it is this find the data here under this block, so it's fine. But if it is not find that guys, so it will send back to the hard disk. So in a similar way guys, it will go to the second block which is D drive and scan the data here under the RAM. If it is find the data, so it is fine guys. Otherwise, it will still send back to the hard disk. So in this way, this process keeps going on. So here guys, indexing comes into the picture. But here indexing guys, it's not reducing the searching time. So guys, the number of blocks you are calling here, these are called input and output cost. So here you are transferring the data from hard disk to RAM. So the more number of blocks you are calling and the IO cost will be increased. Here IO stands for input output cost. And if IO cost increase, so the time will be keep increasing. So what we bring to the actual method guys, so your main motive is that we need to call less number of blocks. And you guys can take the example of books. So when you search the multiple pages guys, so there might be a chance you will get a data on a single page or the worst chance you will get a data on the last page. But if you have a proper indexing guys, you can easily reduce the time of searching the blocks. So indexing reduce the number of blocks, you can say it reduce IO cost. So here indexing reduce the number of blocks. It's not reduce the searching time. So you can say it's also reduce input output cost. So I hope you guys are clear with this example that how indexing reduce input or output cost. And now guys, let's understand how we guys can use indexing in SQL. So let's jump into this SSMS screen. So here guys, I'm trying to open one simple table which is select star from sales and let me hit execute. So this is the table guys where we have taken 60 rows. So if you guys I try to create an indexing guys, there should be a large tables. It should be more than 1000. And now guys, let me write one query here. So I want to fetch only those records whose costing is greater than 500 and less than 5000. So now let me write this query here. Select star from our table name is sales where cost is greater than 500 and cost is less than equal to 5000. And now let me select this query and hit execute. So here we guys can see it's filtered 20 rows out of 60 whose costing is greater than 500 and less than 5000. So in this way you can usually use this query. But this is the small table guys, so it easily fetch the data. But what if guys, if you have large table and if you try to apply the same query, so it will take more time to execute. So the best way guys to optimize this query, if you have the large data set, you guys can use indexing. And with the help of indexing guys, you can easily optimize your query once you have the large data set. So now let's learn how to create indexing in SQL. So what you guys can do, you can simply use create command. And here we want to create indexing. So I'll simply write index. And now you need to call your index name. So I am using short form here, INDX. Although you guys can write another name. So my index name would be, let's say, INDX underscore Shubh. So this is my indexing name guys. And now here I will simply write on keyword and directly write the table name, which is sales. And now let me start this bracket and simply write the column name where you want to apply the indexing. So I want to apply the indexing on cost column. And if you want to sort this column, guys, so you can simply write ascending or descending. So this time I am taking ascending order and bracket close. So this is the way, guys, of creating indexing. And now let me select this query and hit execute. So here we guys can see command completed successfully. And now guys, let me refresh this database. And now guys, let's see where we can see this indexing. So what you need to do, guys, you need to click here on this database and simply select the database name, guys. So here we are using Shubham. And now let's go to this table folder. So we have creating indexing on this sales table. So what we need to do, guys, we need to go here under this sales table. And now let me expand this. So after expanding this, guys, you can see the folder indexes. And now let me click this folder. So here we guys can see the created index, which is index_shub. And here you can see there are two types of index, which is non-unique or non-clustered. So the types of indexing, guys, we will cover in the separate tutorial. This time we are trying to understand what is indexing. So in this way, guys, you can create indexing under the tables. If you try to execute this query on the last table, guys, so this indexing will help to optimize. So there is another way, guys, to view this index. So you guys can use system defined store procedure. I am using the system defined store procedure, which name is help index, and simply write the table name where you apply this indexing. And now let me select this query and hit execute. So see, guys, here index name is index_shub, and this is the index key where you have applied the indexing on the cost column. So this is a, guys, non-clustered index. So I hope you guys are clear with this topic. And now let's discuss, guys, some more points. Let's understand what are implicit index. Implicit index are indexes, guys, which are automatically created by database server. When an object is created, indexes are automatically created for primary key constraint and unique constraint. So these two constraints, guys, we have already covered here under the playlist. And now let's understand, guys, when we need to avoid index. Indexes, guys, should not be used on a small tables. Indexes should not be used on those columns which contains high null values. If columns which are frequently manipulated, so there, guys, you don't need to use indexing. And if we are frequently dealing with the insert, update and delete command, so in that cases, guys, you don't need to use indexing. And now let me explain this last point, that why we don't need to use indexing while using this insert, update and delete command. So indexing can be problematic, guys, if we use this insert, update and delete. Index maintained overhead. Every time you use these three commands, guys, so the data in the table can change. The indexing must also be updated to reflect these changes. More indexing equal to more overhead. There could be a more IO cost and the memory usage during write operations. Potential locking contention, especially in high concurrency environment. Fragmentation. Frequently update and delete can use indexing fragmentation. This leads to inefficient index structure, causes slower queries over time, requires regular maintenance. And the last point says wastage storage. Indexing consumes disk space. If you are indexing the table that is updated constantly, but you rarely read from it using those indexing, you are wasting spaces. So if you're using these three commands, guys, insert, update and delete, so these points, guys, you need to consider in mind. In that cases, guys, you don't need to use indexing. So I hope you guys are clear with this tutorial of indexing. And in the next tutorial, guys, we will talk about types of indexing. So for such kind of detailed learning, guys, stay connected with us and kindly support this channel. And those who are new to this channel, kindly hit the like, share and subscribe. And don't forget to press this bell icon, guys, else you will miss an update. And those who wants to learn Power BI or SQL from scratch, so you guys can follow this free YouTube channel, which name is Analytics Pro. And if you scroll it down, guys, so here you guys can see we have a full course Power BI playlist where I have explained each and every concept about Power BI in detail. And if you click here on this playlist button, guys, so you guys will get to see multiple playlists are here. This is the Power BI full course playlist and these are the advanced concepts of Power BI where you guys can take the knowledge of advanced concepts of Power BI. And we have this Power BI with SQL playlist where you guys can learn all the concepts of SQL from scratch. So you guys can start your SQL journey with this free YouTube channel. And along with that guys, we have this visualization playlist and we have this DAX expression playlist. Here we have covered most of the DAX functions from scratch which are majorly used in your projects. And here under this playlist, I am also trying to cover all the differences of DAX functions which is majorly asked in an interviews. And very soon guys, I will add some more playlists so that you guys can take better understanding of the analytical skills. And for the job seekers guys, we have this free Telegram group where I'm keep posting latest Power BI jobs opening, as well as you will also find some latest interview question and answers which recently asked by an interviewer. So you don't need to pay anything to anyone. But those who are looking only live sessions, so we guys also conduct live training and sessions where we prepare candidates from scratch till intermediate level with some scenarios, real-time projects, assignments, notes and so on. And we also provide placement assistance with the help of WhatsApp group where you will get to see some HR emails, contact number and so on. And you guys can also follow us on Insta as well as Facebook. So all the links I will share under the description box. You guys can follow us there. So for free learners guys, you guys can follow this Analytics Pro, and for the live training and sessions, you guys can connect me any of the platform. Thank you so much guys for your more love and support. Keep learning and keep growing. Thank you so much.